Hello everyone, myself Professor Kishan GS, Assistant Professor, Department of Mechanical Engineering, Maharada Institute of Technology, Mysore. So myself and my co-faculty Professor Purushothamis will be dealing with the third module related to fluid power system for 7th semester mechanical engineering student, the subject code bearing 17ME72. So this is the first session on module 3, that is control components of hydraulic system and hydraulic circuit design. So we are going to study the control components at the first phase, which includes the study on different types of control components, basically considered as control valves, okay, related to the hydraulic system. And the second part will be directly on utilization of the basic concepts of module 1, module 2, as well as the basic understanding of the control components in hydraulic circuit design. So in this particular session, we are going to study the brief introduction on control components, followed by different types of control components or control valves, the symbolic representation, and two types of valves which represents the directional control valves. Okay, what do you mean by control components? See, whenever we have the different components leading to a particular application in a hydraulic system or in pneumatic system, it has to be given with certain amount of direction. It has to be controlled with certain amount of pressure, and since we have the fluid medium flowing throughout the hydraulic system or in the pneumatic system, there should be a controlled flow rate that results in actual output wherein the entire application is being based on. Okay, so in order to do it, we have the control components basically considered as control valves that deals with the identification of fluid in various parameters like its path, its pressure, and its flow rate. Okay, so considering this, we have three types of control valves, that is control components. First one being directional control valve, second being pressure control valve, and the third one being flow control valve. As the name itself suggests, these are the three categories which understands, which we are supposed to understand basically on its functionality. Okay, so first one being direction control valve. What do these particular valve do? These particular valve control the path of the hydraulic fluid from one location to another location such that leads to the actuation of medium in the defined pattern, followed by the pressure control valve. So these are the control valves that resist the system by being over pressurized, means to say that it controls the pressure of the hydraulic fluid which is running throughout the entire system. So if the pressure is less or if the pressure is high, how the pressure control valve compensate these things is the concept what we are going to understand in pressure control valve. Followed by the last one, flow control valve, represented by FCV, leads with the study on the flow rate of the components which are being considered in the study. So here, since the fluid medium is the major component in the entire study, so along the direction, along the pressure of that particular fluid, what is the discharge in which fluid is going to be considered to result in the actual actuation of an actuator is what it is going to be studied here in flow control valve. So we are going to directly study how actually the flow rate is going to be considered or analyzed. Okay, so we have different examples of these three valves here. Under direction control valve, we have check valve, shuttle valve, puppet valve, spool valves, rotary valves, and pilot operated valves. So when we start studying each and every type of valve, we will understand its constructional principle, its working, okay, and where actually these type of valve will be considered, that is its application. Followed by pressure control valve, we have few more cases here. One is pressure relief valve, pressure reducing valve, pressure sequencing valve, pressure unloading valve, and pressure counterbalance valve. So again, these are the five valves wherein we concentrate on to control the pressure of the fluid which is being running in the entire hydraulic system. Followed by the last one, flow control valve. We have two categories. One is non-compensated flow control valve. Another one is pressure compensated flow control valve. So under non-compensated, we have needle valve, okay, globe valve, gate valve, and ball valve. And under pressure compensated valve, we have one particular constructional feature which we are going to study in the class. Now, the next topic goes with symbolic representation. See, a symbolic representation basically goes with different types of control valve what we are going to study. So in case of direction control valve, we are going to understand based on the transverse path of the fluid which is being accounted in the entire constructional feature. So now let us understand the symbolic representation for direction control valve. See, basically in case of the direction control valve, the symbolic representation is taken into account with two parameters. One is ports, another one is position. So basically the direction control valve will be represented symbolically by the letter M cross N as the reference. So M cross N, M being ports, N being positions. So how to understand these particular type of symbolic representation? See, basically we will be considering one single envelope. Within the envelope, we will be having extended projection lines which represents the ports which are accountable for that particular control valve, or which accountable for that particular flow of direction in the fluid. So we will be having one particular envelope, out of which we are going to have the extended lines which are called as ports here. So you can observe here, this particular box is called as envelope, and these two extended lines are taken as ports here. Okay, and between these ports there will be a single arrow headed line that represents the direction of flow from one port to another port. So you can observe in the figure here, there is a line arrow headed from the bottom to the top here, means to say that there is a flow from this particular port at the bottom to the port at the top. Okay, so this is the simple understanding of a block or single envelope. Similarly, we have multiple envelopes and multiple number of ports here. So you can observe here, I have three envelopes which represents three positions in the entire representation. Okay, I have 1, 2, 3, 4. 4 projected lines, which means to say it consists of 4 number of ports. And similarly, we have arrow-headed lines representing the flow from one port to another port. Similarly, from another port to the another port. So here, for the purpose of understanding, we are going to name the port using the term P, T, A, B as reference. So P represents pump port, T represents tank port, A and B represents the system ports here. So this is for the reference, or to make the entire understanding simple, we are going to take these as the references for naming the ports here. So as I already said, for an envelope, the projected lines accountable for number of ports here. See here, for one particular envelope, I have two projected lines here. That represents the entire system consists of only 2 ports. Observe the second one. For that particular envelope, I have 1, 2 and 3 number of projected lines here, or the extended lines. That represents the entire system consists of 3 ports. And similarly, the last one, the envelope consists of 1, 2, 3 and 4. 4 number of extended lines. That means to say the system consists of 4 ports here. Okay. The immediate understanding after the ports goes with the position. Position is nothing but the operating sequence in which the entire direction control valve is based on. See here, if I have only one envelope, that represents only one operating cycle is present in the entire direction control valve. If I have 2 envelopes, means to say that there are 2 set of operations that can be expected from that particular direction control valve. Similarly, if I have 3 envelopes, then I can say it operates in 3 sequences, that we can expect the valve to operate in 3 stages. Okay, that is what the valve here. And one more simple basic note here. See, in case of 2 and 3 positions here, if you represent the number of ports in only one of the envelope, that is enough. You need not to showcase the envelope's presence in all the number of positions here. So please make a note of it. The representation of ports will be considered only for the one box among the number of positions. So you may take it at the center, or you may take it at the first, or you may show it at the last. But you have to show the number of ports as well as the naming of the the ports A, B, P, T into one particular envelope. Okay. So that is M cross M. M cross N. Sorry. M represents number of ports. N represents number of positions. So make it simple. Number of boxes represents N. Number of extended lines represents M. That is ports, and this is position. We have simple example of 2 cases here. See, observe the figure carefully. I have 3 envelopes, 1, 2, 3. Okay, 3 envelopes. I have 4 ports named here, P, T, A and B. So, number of ports / number of positions, that is 4 cross 3. 4 number of ports, 3 number of positions, means to say that this direction control valve works in 3 stages having 4 ports in its operating condition. So, observe carefully my constructional detail here. See, I have represented the number of ports P, A, B and T only in the one of the box. I have not shown in all the 3 boxes or 3 envelopes here. means to say that the representation is such that only one of the boxes is to be showcased with the number of ports or naming to the ports here. So let us now just for the purpose of to create some interest, we will understand what is happening in this particular type of valve. See here, there is in the first position, there is a flow from pump port to the system port A. Simultaneously, remember the word simultaneously, at that position itself, there is a flow from port B to tank port T. Moving on to the second stage of operation, see, we don't have any of the transformation line here. Remember, if at all, if a line with arrow headed is being represented, only that is the case which shows the direction of flow of fluid, okay, as represented here. It has to be a line with arrowhead. So here you can observe there is no line with arrowhead, means to say that in second stage the condition is off, means there is no flow taking place from either pump to system port or system port to tank port, okay. Moving on to the third stage, you can observe here, see, this is P, this is T, this is A, this is B. From P, there is a flow to port B. Similarly, from A, there is a port to, there is a supply to tank port T. So, whatever we represent here, that is a fixture, P, T, A, B is fixed. So, however the stages in which the direction of flow of fluid is accomplished, that is what we are going to represent in the different number of stages, okay. So, similarly, we have 3 cross 2 here. 3 is number of ports. See, I have P, A and T, only 3 ports. 2 is number of positions. I have 2 envelope. So, in the first envelope, there is a flow from pump port to the system port P to A, and there is no supply from tank port. Whereas, moving on with the second position, there is no supply from the pump port here, whereas there is a supply from system port A to the tank port T. Means to say that it operates in 2 stages, P to A in one and A to T in the second stage, okay. So, this is the basic understanding of symbolic representation for direction control valve. Remember the term M cross N. M is number of ports, N is number of positions. Number of ports is nothing but number of openings provided in the valve. Number of positions is nothing but the different stages at which the valve can be considered for its application or its usage, okay. So, simple construction of the direction control valve. We are going to study 2 valves here. One is puppet valve, another one is 3-way valve. As we are studying the concept of direction control valve, you should always keep in mind these valves represents only the direction path for the fluid to flow in the entire system. From one location to another location, only the direction is matters here, not the pressure and flow, okay. So, observe the figure carefully here. So, there is a ball which is considered to be the puppet here, and this particular ball is assisted by the compressible spring here, okay. So, if you press the ball against the spring, the construction is such that the gap between the frame will be open for the flow of fluid, okay. How to go with the movement of this particular ball, okay, against the spring pressure? We are going to go with the puppeting action by the application of load by the plunger, okay. So, observe the number of ports here. I have pump port P and I have system port A, okay. Now, I have no loading condition applied, means to say that the entire system is under cutoff condition, okay. Now, if I start applying the load from this particular plunger, what happens? The load which is applied on the plunger will be applied onto the ball here, so that the ball will be compressed against the spring. Once the ball is compressed against the spring, the area in which the ball has occupied will be vacant, will be open for the fluid to pass from pump port to the system port A. Means to say that once the ball is moved off its seat against the spring, the fluid will flow from P to A, okay. Once you release the plunger, the ball come back to its original condition, original position, such that the flow from P to A is cut off, okay. So, this is what we are going to study in the puppet valve. So, apply the pressure, allow the fluid to flow, release the pressure, and thereby cut off the supply. Now, we are going to study the same thing in the graphical symbol here. See, how many ports do I have? 2 ports. So, I have P and A. What is the position? First position is apply the load on the plunger, allow the fluid to flow. Second position, remove the load, the plunger come back to its original position, the ball come back to its original position, there will be no flow. See here, I have 2 envelopes that represents 2 stages of operation of puppet valve. See here, first one, when you applied the load on the plunger, there is a flow from P to A. There is a flow from P to A. Okay. Whereas once you release the plunger, what happens? There will be no flow taking place from P to A. This is the cutoff symbol. So inverted T and the upright T position represents the cutoff condition of the supply. That means to say that there is no supply taking place from P to A in the second condition. That is what we have understood in the puppet valve. See here, this additional representation of spring and a plunger type represents the type of construction in which the direction control valve is being considered. Okay, so these are all not mentioned here because these are all specific to what type of control valve we are studying. Okay, but this is the constant understanding. Two ports, P and A, two positions, that is when you press the plunger, there will be flow. Once you release the load, that particular flow will be cut off. So here we have pressed the plunger, so there is a flow. You have released the plunger, there is no flow. Here the assistance of retraction is using spring here, hence this particular representation is taken to the right side and the plunger is taken to the left side. So those are the assisting components which results in the working of the puppet type of direction control valve. See here, two ports, that is M. So I have written 2 slash number of position is how much? 2. One is to open, one is to close. So it is 2 cross 2 puppet valve. M is 2, N is 2. So hence it is 2 cross 2 puppet valve. So for every valve, you have to write this particular symbolic representation without fail. Okay. So next, moving on to the last one, that is three-way valve. Okay. Here in this particular valve, observe carefully, we have written the symbolic representation at the top position here. So this is a single valve which is considered for two positions of its operation. So this is, observe here, spool position 1, spool position 2, means to say that the valve is working for how many positions? 2 positions. So in the symbolic representation, what should be the number of envelopes? 2 envelopes. See here, I have 2 envelopes. So according to the construction, how many ports do you have? You have a pump port, you have the tank port, you have the system port. That is, the number of ports is 3. So means to say that we have P, A and 3. So 3 number of ports, 2 number of positions. So this is considered to be 3/2 direction control valve. Okay, just like this. Okay, it is 3 ports, 2 positions. Now let us understand the construction of three-way valve. See, three-way valves are nothing but spool type of valves. Okay, in the direction control valve, it is nothing but spool type of valve. Here we have to understand what is a spool. See, a spool is the component which is present between the valve body such that it consists of a shaft with extended projection which is equal to the diameter of passage given in the valve body. Okay, so if I just go with this particular position, see, this is the shaft. In that particular shaft, I have this 1 and this is 2. So 1 and 2 are the 2 extended enlarged circular portion bodies which are equal to the diameter of space available within the valve body. Okay, so that is nothing but spool. Here, this movement of spool is the consideration here. So you can observe the spool position 1. In case of this particular movement, okay, the movement of spool is towards the right side such that it is not right and left. It has to be understood like this. When the spool is moved towards right, there is an opening provided from pump port to the system port. See, there is a flow taking place from pump port to the system port. This is the position of spool 1. Now consider the position of spool 2. The spool is now moving from right to the left. When it has moved from right to the left, there is no flow from P to A. Instead, there is a flow from A to T. Okay, there is a flow from A to T here. T is the tank port, P is the pump port, A is the system port. Keep always this in mind. Tank port is always a receiver end. So wherever we represent, there should always be a flow from any of the port to the tank port, whereas from tank port, you cannot directly allow the fluid to pass through into any of the system port. This is a simple common sense wherein we have to remember for the next classes as well. Okay. So here there is a flow from system port A to the tank because see, blindly there is a mindset wherein we can represent the flow from T to A. T to A is impossible. Tank is a reservoir. It receives only the fluid what it has been sent into. Okay. Hence, keep in mind, there can always be a flow from system port to the tank port, or pump port to the tank port, pump port to the system port, but there will never be a flow from tank port to any of the system ports here. Okay. So observe these two positions in the graphical symbol now. See, we have two positions, so we have two envelopes. We have three ports P, A and T. So the three ports are represented here. So observe the first condition. What is the condition? There is a flow from P to A and there is no supply to the tank here. So there is a representation from P to A and T is cut off. Moving on to the next position, there is no supply from P. So P is cut off, but there is a supply from A to T. Observe here, A to T. So A to T. So this is the symbolic representation for the three-way valve, that is a three-way valve spool type of direction control valve. Thank you.